Hello everyone. In this video, I'm going to take a look at an acid-base question. And the question reads, 12 cm cubed of sodium hydroxide of concentration 0.1 mole per dm cubed and 48 cm cubed of barium hydroxide of unknown concentration are mixed in a large flask and the solution homogenized. I'm going to draw it out. So suppose that's my flask. In this flask, I have 12 cm cubed of the NaOH. It's not the best drawing, but it does the job. Concentration 0.1. And in here we are also adding 48 cm cubed of my barium hydroxide. The concentration here being unknown. This solution is completely neutralized by 54 cm cubed of a 0.05 mole per dm cubed H2SO4 solution. So 54 cm cubed and the concentration being 0.05 moles per dm cubed. The question, and this question was worth 8 marks, calculate the concentration of the barium hydroxide solution. So let me show you how we could do this question. The first thing I would do is I would try to write out a reaction. Now, because I have H2SO4 and then I have the barium hydroxide and the NaOH, it can be a bit confusing as to what reaction we're going to use. So instead, let's just write a general neutralization reaction. So what is neutralizing what? When an acid and a base neutralize one another, you're going to have the H plus neutralizing the OH minus or reacting with the OH minus and going to give you water. Right? Now we can examine the H plus and the OH minus. And we can clearly see that this is in a ratio 1 to 1 to 1. Now the H plus is going to come from the acid. In this case, the H2SO4. So let's start with that. So the H plus is going to come from the H2SO4. So let's calculate the number of moles of the H2SO4. Number of moles is going to equal concentration times volume. 0.05 multiplied by 54 over 1,000. And that's going to give us 2.7 times 10 to the negative 3 moles of H2SO4. But we need to be careful. That's not going to be the number of moles of H plus. H2SO4 is diprotic, which means that the number of moles is going to be double. So to get the number of moles of H plus, it's going to be 2 times 2.7 times 10 to the minus 3, which is equal to 5.4 times 10 to the minus 3. Now that we have the number of moles of H plus, we can use a mole ratio to get the number of moles of OH minus. So because it's in a 1-to-1 ratio, the number of moles here is also going to be 5.4 times 10 to the negative 3 moles. Now that we have the moles of OH minus in total, we can now break it up and figure out how many moles of OH minus came from the NaOH and how many moles came from the barium hydroxide. So this OH minus is going to break, right? Or instead of saying break, we're going to examine it closer. How many moles came from each one? So the moles of OH minus from the NaOH, we can calculate. We can say the number of moles is equal to concentration times volume. For the NaOH, the concentration was 0.1, the volume was 12 over 1,000. That's equal to 1.2 times 10 to the minus 3. Now, because NaOH is monoprotic, when it breaks, the number of moles of the Na is going to, the NaOH is going to be the same as the number of moles of the OH minus. So it means that the number of moles of OH minus is also going to be 1.2 times 10 to the minus 3. So if I have a total of 5.4 times 10 to the minus 3 moles of OH minus and 1.2 times 10 to the minus 3 came from the NaOH, if I subtract the two, I'm going to get the number of moles of OH minus that came from the barium hydroxide. So the OH minus that came from the barium hydroxide is going to be 5.4 times 10 to the minus 3 minus those that came from the NaOH. And that's giving us 4.2 times 10 to the minus 3 moles of OH minus from the barium hydroxide. Now the question is asking about the concentration of the barium hydroxide. So we need to look at the dissociation of barium hydroxide. Barium hydroxide is diprotic. In other words, when it breaks, you're going to have, so barium hydroxide, when it breaks, you're going to have Ba2 plus and 2OH minus. If the number of moles here is 4.2 times 10 to the minus 3 as we calculated, the number of moles of this is going to be half because the ratio is 2 to 1. So the number of moles here is going to be 2.1 times 10 to the minus 3 moles. Now that we know the moles of barium hydroxide and we know the volume of the barium hydroxide, we can calculate its concentration. The concentration is equal to number of moles divided by volume, 2.1 times 10 to the minus 3 divided by 0.048. That 48 I've divided by 1,000. And that gives us a final concentration of 0.04375 moles per dm cubed. Now, of course, there are multiple steps here. And so it is difficult for most people. So I'm going to present you with an alternative. Right? And let's look at the alternate method. Now, the alternate method is dependent on you being able to write out reactions. So let's start again with our flask. In this flask, we have 12 cm cubed of NaOH. And it had a concentration of 0.1. Then we had 48 cm cubed of barium hydroxide. And the concentration was unknown. We added in 54 cm cubed of the H2SO4 and the concentration was 0.05. So, to work this method, we're going to imagine, or we're going to work with volumes here. So first, we're going to work out what volume of H2SO4 was actually needed to neutralize the NaOH. Because it couldn't have been 54 cm cubed. Because if 54 cm cubed was used to neutralize the NaOH, then there would have been no volume left to neutralize the barium hydroxide. So we'll look at the reaction between H2SO4 and NaOH. So H2SO4 plus NaOH is going to give us Na2SO4 plus H2O. Now we need to balance this, so we'll put a 2 here and we'll put a 2 there. Now, because we know that the NaOH was completely neutralized, we can use the formula CAVA over CBVB is equal to NA over NB. And remember, we want to work out the volume of H2SO4 that was used to neutralize the NaOH. So the concentration of the acid is 0.05. The volume of the acid we don't know. The concentration of the base is 0.1. Volume of the base that was neutralized is 12. And remember, when you use this formula, you don't need to convert. And that's equal to 1 over 2. So the volume of the acid is going to be 12 cm cubed. So that means of the 54 cm cubed of H2SO4 that we started with, only 12 was used to neutralize the NaOH. That means the balance 42 cm cubed must have been used to neutralize the barium hydroxide. So I'm writing it as 42 cm cubed for the barium hydroxide. Now let's take a look at the reaction between the H2SO4 and the barium hydroxide. So H2SO4 plus barium hydroxide is going to give us BaSO4 plus H2O. Let's ensure that this is balanced. To balance, I need to put a 2 here. And I can use the same formula again because the barium hydroxide was being completely neutralized. So CaVa over CbVb is equal to Na over Nb. The concentration of the acid is still 0,05. The volume of the acid, we know now it's 42, divided by the concentration of the base, which we want to work out, and the volume of the base was 48, and that's equal to 1 over 1. So that means the concentration of the base is going to be 0,04375 moles per dm cubed. And that's it. Thanks so much for watching. Don't forget to like, share, and subscribe for more. Good luck for tomorrow. Bye-bye.